veterans like me. So I'm logged in now, so go ahead and log in, everybody. And let's do what we normally do. Let's work together here. All right, we got, let me see. So Ariana's logged in, Odessa's logged in, very good. Tyler, good morning. So let me see. All right. So Tyler, where are you, buddy? Let's go ahead and speak up. I want to test the sound system because everybody in the classroom here can hear you if you speak up.
Okay, hi.
Ah, there you go. Say hi to everybody because you're seeing the class in here. So say hi, everybody.
Hey,
Speak
guys.
up. He can hear you from my mic, and then of course we can hear Tyler too as well. Seth, go ahead and give me the rocky thing. Let me see if Tyler can hear you. Go ahead. Say something. Can you hear Seth, Tyler?
Yeah, I can.
All right, let me log in. Let me get the other camera going here, and then we'll get started. Everybody needs to have their notes out. Tyler, go ahead and print off 7B2 prep that's online. Let me show it to you on the screen. Looks like this right here. And everybody get Desmos going. Now, if you want to use Desmos on your phones, so you can see, you don't have to go back and forth on your screens. You should be able to download it on your phone if you don't have it downloaded already. And since we have a loudspeaker here in the classroom, you don't need earbuds. So let's take out your earbuds because you do not need them. I don't want you guys listening to music and doing all that sort of thing. So no earbuds in class. You don't need them because I have a loudspeaker for everybody online. So as you guys get ready there, everybody online needs to print off 7B2 prep. There, looking sharp there, Tristan. Looking good. Everybody online, start printing off 7B2 prep number 2. Get Desmos going. And I'm going to log in the second, I'm going to log in twice so you guys online can see everybody in the classroom. So let me get that set up right now. If there are any questions or needs as we get started here, let's address those first. Okay, so give me a second here, everybody. I need to get the chat going and my participants in here. Aha, good morning.
Morning.
Who am I speaking to?
Daniel.
Daniel. So pick a spot, over here is where you have a good view of the screens up here. And then hopefully we have a few more people coming in here. It's good to see everybody online too. I see Maya and Kylie. Everybody turn your cameras on so I can see you. Everybody in the classroom is going to be logged in again as well. The people in the classroom, keep your cameras on too. If you have your cameras on, you need to turn them on as well. Everybody keep your cameras on so the people online can see you guys. And then of course I can see you, I can see them, we can see each other here. I'm going to log in twice so that you can see the classroom as well. I'm going to be working on that. Daniel, do you have your notes?
I do.
Okay, go ahead and take those out. Everybody get Desmos going here. I'm going to log in again over here. All right. Give me a second, everyone. I need to get logged in over here. Okay, so 8, 4, 8.
Mr. Ainsworth,
Yes.
my computer's having a problem trying to print out this page, so I'm gonna have to restart my computer real quick.
Okay, I have an idea for you. And before you do that, did you download it to your desktop first?
Download what, the printer or?
The document. So you, instead of printing it, you click on the link, and then you download it to your computer. Did you try to do that yet?
No, I'm doing that right now.
Download it to your computer, and then once you download it to your desktop, then you print it from your desktop. I think that will work for you because some people are having issues printing it directly from the internet, when you open it up. So download it first and print it. That should work. Okay. So let's see here. I need to have everybody turn your cameras on. I mean, inside the classroom and outside the classroom, so that everybody can see everyone. So I'm talking to, Kaylee, Bailey, Vanessa, Matthew, all you guys. Please turn your cameras on. Thank you. I appreciate it. First of all, good morning. It's good to see everybody. It's good to have everybody back in class. It's been, it's about time that we get this thing going. And hopefully before the end of school, hopefully they open it up to 100% back, instead of only 50% where we're at. So I'm hoping for that. And that way I can get to see and meet everybody, live, obviously in person. So we're gonna be talking about 7B2 prep number 2. It's online. You need to print that off if you're at home. And if you're not at home, I need to give it to you. In the future though, guys, you're gonna have to print all the materials off the night before. Today I'm gonna give you one because obviously this is day number 1. Okay, and you guys didn't have this available at that point. So I think I gave you guys, and take out your notes. You're going to need notes later on. So just make sure you bring it tomorrow or the next session. This is for today, Dan. Thank you. You're welcome. All right. So believe it or not, everybody online, or everybody in the classroom can hear everybody online, because I have you guys on loudspeaker. So Tristan, why don't you greet the class here? Turn on your mic and greet the class. Say hi to everybody.
What's good?
That was enthusiastic. All right. So you guys can hear one another here because your voices are broadcasted out loud in the classroom. So we're going to use our mics more often now, not just the chat, but we're going to be using your mics to ask questions throughout the period. For you guys in the classroom, you just raise your hand, speak up, ask questions as you normally would. You don't need to have microphones or earbuds or anything because their voices online are going to be amplified through the speakers. And so you're going to be able to hear their responses. And then when you speak up, if they can't hear you, I'm going to repeat your questions or repeat your responses so that everybody online can hear you. Because even though my mic's right here, if you speak up really loud, they probably can hear you. But if they can't, I'm going to be obviously facilitating that. Are we good? Okay, so I want you guys to just act like you're normal. You're here. You chose to be here in class. And so just act normal and speak up, ask questions. And then everybody online, again, use your mic a lot. And that way that, everybody can hear what's going on.
Why don't we test if we can hear them or not while we're still getting situated?
Okay, so let's do that here. So Spencer, you're pretty far away. So Spencer, why don't you speak up as loud as you can and tell everybody how your day's going.
Going good.
All right, give me a high and low.
Almost tripped down the stairs.
In the 300 building?
Yeah.
Can you guys hear him? Okay, keep going, Spence.
That's pretty much it.
Oh, that's a low. Give me a high.
I got coffee.
Okay, all right. So do I actually. All right. Dan, give me a high and low for today.
Low. I was a little late later. Then I got here at 9:10, which is not really on my part. And then low, well, a bit of low. High, woke up today. I mean, that's always a high. You know?
All right, and you're here at school.
Yeah.
Can you guys hear Daniel online? Can you guys hear him? Give me some feedback. Okay, well,
Yeah.
that's pretty amazing that with this little teeny microphone, I can get voices all the way back. You know, let's Odessa, give me a high and low back there. Let me hear from you. You guys speak up for me there.
I got here early even though I thought I wouldn't.
You got here earlier than you thought you would. That's good.
Just like the high and the low. I'm just really tired.
Okay, well, you're not alone. Now, a lot of people, especially period one, said, they were tired, coming here because you have to actually get up now early. Like to me, today I got up at 5 a.m. because I live out in Wildomar and I have to get here early to get everything set up. And I also have to, get everything set up here and everything ready for you guys. And so I have to get up really early, and it takes the body at least a couple weeks to adjust. That's probably what's going to happen for you guys because you're used to being online and waking up fairly late. Don't have to worry about going to school. And now that you guys chose to be at school, it's going to take some transition. So that's to be expected. So Berkeley, tell me about your trip. I know that you went on a trip that was, a big trip here. Give me some high points on your trip.
So I went on a college tour. I went to Humboldt, Chico, Sacramento, and Fresno. So we started off by going to Humboldt first, but when we were driving over there, we stopped at a family's friend's house, and she lives I don't know where it is, but it's just covered in greenery and it's so pretty. Her backyard, she has a creek and stuff. It's super cool. And then we went to the glass beach also with the sea glass. And then we went up to Humboldt. Did not like Humboldt personally. It was very not clean. Eureka is not pretty at all. It's very beaten down, I guess. And then we went to Chico. I fell in love with Chico. It's so pretty. It's everything I want in a campus. It has that brick, but it's also super green and stuff. So I think I'm probably gonna end up there. Then we went to Sacramento. That was nice too. It was modern and the squirrels were nice. I like the squirrels. And then same with Fresno. Fresno is so big. I walked on there and I was so exhausted when we finished walking around everywhere. It was crazy.
You're going to be focused in on Chico?
I think so. I really like Sacramento, city-wise, but campus-wise, I think I want something more of a college town, which Chico has. But I'm really close to Sacramento still, so I can just drive down when I get my car.
Chico's a little bit further away. I had a friend in Chico when I was in college, and I went up there a few times, and it is beautiful. I agree with you on that. That's awesome. Did anybody else have any college tours over break? Because obviously this is the time where seniors are going out of town, checking out different colleges. Does anybody want to share on anything they did? If you did do something like that? Goes out to everybody. And then Jalen, Bella, Matthew, Courtney, and Ali, you guys need to turn your cameras on here. That is not a request. It's kind of mandatory to be part of the classroom here. I do not want to play a hardball and remove you from class if you do not have your cameras on, but I will if that keeps on being a problem. So you guys need to talk to me about what's going on. And I'm sorry about that. You guys, Jalen, Matthew, Courtney, all you guys need to respond here. Because if you don't, that means you're not there and I'll be removing people from class. That goes for anybody, by the way, in all my classes. It's a standard policy. So if I don't get a response from you, that's what's going to happen. Expect that. I hate to play that way, but you guys need to respond to your teachers when you come to class. It's just one of those things. There we
Hello,
go.
I messaged you. Yeah, I'm printing out my worksheet right now.
I know, but there's no reason to turn off your camera. You can just print off. I mean, it's not a big deal.
Okay, yeah, no worries.
All right, thanks, Jalen. I appreciate it. Courtney, Ali, where are you guys?
I just got back from printing off mine. I'm setting up everything right now.
Very good, thank you. Ali, I got your message there. Understood. I understand it's sometimes there's certain things going on online that prevent the camera use, but more, 90% of the time, I want, everybody's cameras on, just because it's better that way. Because I know that you guys would not come to my Zoom sessions or class sessions if my camera's off and audio's off. You just wouldn't come, right? Does that make sense? That's pretty obvious. Okay. All right. Well, first of all, it's good to see everybody back. It's been 2.5 weeks. So what we need to do before we get in this lesson here is to do a little review on 7B1. So if you have your notes, turn to 7B1. And I'm going to also put this up on the screen because what we learned in the past is going to be needed today. And everybody needs to have your notes out at all times, whether you're online or in the classroom, it doesn't matter. You always have your activities. Okay, go ahead. And then just look at the screen here so that you guys can see what's going on. So this is 7B1. Let's just review what we learned. And again, this is 2.5 weeks ago. And I don't assume that you guys remember, 100% of things because that's asking too much. But look at the screens here. Let's take a look at what we learned. Okay, so let's, and this is the thing that's going to be a challenge too, because I'm going to walk around the classroom. So those people online, you'll have to just listen. You should be able to hear me no matter where I go. Okay, so let's bring our eyes up here since you guys can see the screens. And okay, so in the part A here, we got y equals x minus 1. We have an x-intercept at 1, or a 0 at 1, because 1 minus 1 is obviously 0. Notice the exponent is 1, which is odd. 1 is odd, right? And notice the graph here, it's a linear function, and it crosses the x-axis at 1. So when we had an odd multiplicity, it crosses. And we found that that happens every single time. On part C, we have x minus 1 to the third power. The third power is odd, obviously. 3 is an odd number. If you look at the graph, it crosses at 1. It doesn't bounce off at 1. It crosses at 1. Anytime you have an odd multiplicity, it crosses through the x-axis wherever the x-intercept is. Like on the part E, x minus 1 to the fifth power, that's odd too. It has a multiplicity of 5. If you look at the graph that we came up with here, when we use Desmos, it crosses at 1 again. So odd multiplicity, it crosses. Even multiplicities like part B, when you have a squared function, even is like 2, 4, 6, 8, right? You have a different situation going on. On the part B, the second power, it looked like a parabola and it bounced off the x-axis at 1. That's a totally different behavior, right? And then on part D, the fourth power that's even, multiplicity of 4, it bounced again. And then sixth power on the last one, obviously multiplicity is 6 or even, and it bounces there again. So we're going to take these ideas and we're going to expand on them, okay? So having said that, let's go to the prep. So let's transition here. Here we go. Grab your pencil. And again, if you have a red pen, take it out because I'm going to annotate in red. Always have 2 colors. Go pencil and red pen. And highlighters too if you need it. Okay? Okay, so let's start off with some vocabulary here because the main goal of the lesson is, graphing and writing functions in this activity. But you have to know the difference between the 3 words root, 0, and x-intercepts. Okay, so let's talk about them one at a time. So when we talk about the word root refers to a solution. So if I give you an equation, let's say x squared minus 3x plus 2 equals 0, that's an equation, not a function. It's an equation that's set equal to something. And I ask you to find the roots, I'm simply asking you to find the solutions. Okay, so how would we do that? So let's do a little review here, guys. What do we do first? And this goes out, when I talk to the group, guys, I'm talking to everybody online too. So it's not just my class, it's you guys online are also my class. So it goes out to everyone. I'm talking to everyone. How do you solve this equation? What's the first step to handle this, to find the solutions? What do we do?
Factor.
Okay, so Daniel said factor. That's a good idea. So let's factor. So let's factor first. Here we go. So we gotta factor the polynomial as something times something equal to 0. So we got to factor. Oh my God. So let's start thinking about this. And you guys know how to factor here because you guys are seniors. You've been through algebra 1 and 2. There's multiple methods. You can use the box method, the FOIL method. I personally use the FOIL method. I don't know about you guys. I think, what two numbers multiply to 2 and add to that positive 3. You know how to look at that function to determine those factors. In respect to the FOIL method, which I use here, I know that the first factors have to be x, because x times x is x squared. But is it x plus or minus something times x plus or minus something? What is it? So you guys got to be thinking, what two numbers multiply to 2 and add to a negative 3? What two numbers multiply to 2 and add a negative 3? Okay, and those are some good ideas right there. There you go. So everybody, you guys are, even in the classroom, we're going to be using the chat, but I also want you to get vocal here, guys. And the people online, I want you to get vocal too. So notice what the people already started responding to the chat, but you guys can make it quick and easy to speak up, right? You just give me some numbers here, some values, we can have a discussion. So -2 and 1, let's see if those actually work. So -2 times -1 is +2, I like that. -2 plus -1 is -3. So I like those values actually. So Jalen, when you go to the chat, try to put things out to the whole class, because not everybody saw that. And then Tristan put something to the class too. He said x minus 2 times x minus 1. I like that. Okay, so x minus 2 times x minus 1. Now what? We factored it. Now what do we do?
Set them to equal to 0.
Set them equal to 0 and use what's called the zero product rule. Okay, so let's use the zero product rule. Now, if you don't remember what that means, it means this right here. So if A times B equals 0, then either A has to be equal to 0 or B equals 0. This is called a zero product. When you have something times something equal to 0, it's called a zero product. So what Daniel said was that you take each one of these and you set it equal to 0 and you solve them. So let's do that. So x minus 2 equals 0, and then x minus 1 could be equal to 0. Okay, so if we solve both of those, we get a couple solutions, which we call roots. So what are they? What are the solutions of the roots? You guys can speak up here. What are they? What do you guys see?
X equals +2 and x equals +1.
Agree or disagree, guys? Okay, Berkeley, I don't know if you heard everybody here, but they agreed with you, okay? So 2 minus 2 equals equal to 0, so x is obviously 2 here, and then 1 minus 1 equals 0, so 1's here. These are called roots, okay? These are the roots or the solutions of the equation. So it has two. It has two roots or two solutions. Okay, so the word root refers to the solutions of an equation. Are you guys good with that? Vocabulary-wise? Okay? Because you have to understand what the words mean. Otherwise, you're going to get lost. Now, the word 0 is different. Okay? The word 0 is used in the context of functions. Okay, so notice that I have a function here. F of x, call that a function, is equal to x squared. There you go, use those extra s. Oh, and by the way, for everybody in line, if you notice that your battery is running down, I have outlets everywhere for you guys. And if you guys got to bring your power cords, and you can charge up as you use them, because you have to be prepared for your next class. And you don't want to have your computer die out in the next class. So I have, give me a second here, guys, because I'm just talking to, there's one here that you guys can share. There's one behind you right here. And you guys have one you can share over here. And then, Danny, there's, you can use this one right here. You just bring it over here. Just make sure your computers are charged up for your next period too. You don't want to have any problems. You want to participate in all your classes, right, guys? Okay. Sorry about that, everybody. Okay, we're just getting used to this new MO around here. Okay, so the 0 of a function is the value that makes the function equal to 0. So it says show that f of x equals x squared minus 3x plus 2 has zeros at x equals 1 and x equals 2, which means we have to substitute the values in the function, and it better be equal to 0. So let's do that. Here we go. So let's add x equals 1. Okay, we have to substitute 1 in your function and show that f of 1 better be equal to 0. So this is a substitution. All right, we got to take the value of x and we got to substitute it in where we see x. So here we go. Let's do it together. So I see x squared, or 1 squared, minus 3 times 1 plus 2. Does that equal 0? Yeah, Shane, I just read your little message there online. You know, it depends on, you know, everybody has a different computer. And that's why, you know, I put so many outlets here in class, just in case your battery life is not very good. I know, and my older computers have the same battery life. It's not very good. So we're gonna need to charge them up frequently. So give me some feedback, guys. Does f of 1 equal 0 up there?
Yes.
Okay, let's validate. So this is equal to 1. 1 squared is 1 minus 3 plus 2. And if you work left to right, you get negative 2 plus 2, or you get 0. So f of 1 equals 0. This is called a 0. And 1 at x equals 1 is called a 0 of the function because it makes the function equal to 0. That's where the name comes from, if you didn't know. Okay. Now we need to show that the other, at x equal 2, we have another 0. So let's do it again. So at x equals 2, you got to evaluate the function at 2 now. So work ahead of me here. Does that give you a 0? Okay, so you guys need to be working ahead everybody should be working ahead right here. Okay, so you got to substitute that in. Is 2 squared minus 3 times 2 and then plus 2, does that give you 0? I see Seth, Daniel. How about everybody else? If everybody give me some physical feedback online, because I'm looking at everybody online right now. Thank you, Shane, Berkeley. Maya, are we good? Do we get a 0 up there? Okay. Okay, I see you guys. So we have 4 minus 6 plus 2. Again, you get negative 2 plus 2, and that definitely does give you 0. All right, so we call these zeros of the function because they make the function equal to 0. That's where the name comes from. It's kind of self-implied, isn't it? Okay. All right, so when we talk about zeros, they're just values that make the function equal to 0. The third thing that we need to talk about are called X-intercepts. Now, X-intercepts refer to the graph of the function. So we need a graph for this function. So do you guys remember what this function looks like? X squared minus 3x plus 2. Do you remember the name of the function? Did you guys hear Daniel over here? He said parabola. Let's write that down. So parabola. And this parabola doesn't have x-intercepts at 1 and 2. I don't know. So what's our best friend here? Graphing utility. What's our best graphing utility that we've been working with for a long time? There we go. Yeah, you're right, Destiny. Very good. And Shane agrees with you. Desmos. So let's use Desmos. Everybody, now, for the people in class, what I suggest you do tonight, if you can't do it now, if you don't have it on your phones at home, download it on your phone. It's free. It's a free app. That way you have your computer here, you got your little phone with or you can bring your iPad in. The iPad, you can download the app too, and you can use your phone and your computer real easily. Otherwise, you're gonna have to use your computer. And so everybody open up a tab on Desmos. I'm gonna do the same thing. Look here. And we're gonna type it in. So everybody start typing it into Desmos. I don't care whether you use your phone, your iPad, or your computer. It doesn't matter, but you gotta use something. Because we've been talking about Desmos for a long time. You're going to see that it's going to be needed in the activity here pretty soon. Okay, so y is equal to x squared minus 3x and then plus 2. If you guys, if anyone, whether you're online or in the classroom, if you have questions on the technology about anything, don't hesitate. Just turn on your mic. Speak up. Everybody in the class can hear you guys because you're on loudspeaker. And that way I can address all the questions. That would be most efficient that way, I think. okay? Now in Desmos, what's cool is that it gives you some very important information. It gives you the y-intercept, so click on the y-intercept at 0, 2. Put your cursor there and click on it. It also gives you information on the two x-intercepts at 1, 0 and at 2, 0. And it gives you the vertex as well at 1.5, negative 0.25 or negative 1/4. Okay, and so what we can do is we can use that and come over here and sketch. Okay. Are you good on the input? Do you know how to access the exponents on there?
Yeah.
Okay. Okay, so there you go. So go ahead, let's go to your papers here and let's sketch those points. We have one at 0, 2. Obviously we have one x-intercept at 1, the other one's at 2. All right, the low point, the vertex is at 1.5, negative 1/4. So estimate that. And then another point that you graph is 3, 2. And because of that, you can do a pretty good sketch on your paper here by using Desmos, okay? It's a parabola, an upward facing parabola, which has two x-intercepts, okay? We have an x-intercept at 2, so which is at 2, 0, it's called an x-intercept. And then we have one at 1, 0. There we go. So when we refer to x-intercepts, we're talking about the, where the function, the graph, intersects the x-axis. Okay, it intersects twice. Okay. So I've talked about three things so far today. I've talked about, at the very top, I talked about the word root, which just simply means solutions. Then I talked about the term 0. A 0, the function is simply with a value that makes the function equal to 0. And the third thing I just spoke of is that, wherever the function intersects the x-axis, okay, this is the x-axis on the horizontal, okay, is called an x-intercept. It refers to the graph. So let's pause here and reflect and ask questions. And if you don't have any, type in all good in the chat to just make sure that you guys are understanding what I'm saying here. Or you can give me physical feedback in the classroom too. Okay, thumbs up or down. Thank you, Marianne. There we go. It's good to see everyone. Thank you, Bella. Okay, Destiny, Daniel. Okay. Okay, so just a little terminology there. Let's get into the main lesson of the day to get us ready for the activity. Okay, so let's turn the page and let's go to the back side. Okay. So we're going to be dealing with polynomial functions only that are continuous. They don't have holes, no asymptotes, no gaps or anything like that. These are polynomial functions. The roots are R1, R2, R3, R4, as stated at the very top there. And they can be written in the form two ways. The first form is this one right here. F of x can be equal to x minus R1, where R1 could be 1 or negative 3, depending on the equation. Times x minus R2, times x minus R3, etc., depending on how many roots or x-intercepts it has. And then the second way it can be written, that you guys are going to be using, is using multiplicity, where you have x minus R1 to the nth power, where n is some positive integer. So help me out here. Let's stop right there. Let's make sure that you guys know what positive integer means. So can you guys tell me the first positive integer?
1,
Okay, what's the next one?
2,
Go on.
3, 4, 5, 6.
Go. Thank you. So I want to make sure that you guys know what positive integers look like. So 1, 2, 3, 4. So if n cannot be negative, if n was negative, you wouldn't have a polynomial function. You would have rational functions, and that looks totally differently. Okay. So we're going to be dealing with multiplicities. N refers to the multiplicity of the root. Okay, so remember, odd versus even, multiplicity, one where it balances, one where it crosses, okay? So let's look at graph 1. And then 2, we'll analyze 3 different graphs here. This will help you out with the first part of the activity. So obviously we have an x-intercept at 2. That's obvious. Okay, so we have one root. Okay, we have one x-intercept. Okay, at 2. So let's analyze a little bit further here, and let's talk whether it bounces or crosses. So what do you see? What's going on at 2? Let me loud and clear up here. Does it bounce or cross at 2? Okay, so it bounces at 2. So right here, it bounces at x equals 2. Okay, so it bounces. Well, I should wrote it down here. So it bounces at x equals 2. What does that tell you about the multiplicity? Does it have to be odd? And everybody online, give them both 2. Use your mics if you want. Okay, does the multiplicity have to be odd or even?
Even.
Okay, so that tells you if it bounces, it has to be an even multiplicity at that root. Even multiplicity, so meaning 2, 4, 6, some number like that. So believe it or not, guys, if you know that information, it is possible to write the function in the form of those 2 forms at the very top. Tristan. So how
That's
do you write
good.
that? Okay, I'm just making sure you're listening with me here and you're focused.
Oh, I'm focused, man.
Fired up too, that's good. Okay, so we have to write a possible function, and there's more than one possibility here. So knowing what you know so far from the first activity and what I've talked about so far, how can we write a function for this? What could one possibility of the function be? Again, we refer back if you want in your notes to look at 7b1 because we did a lot of examples like this.
Plus 2 squared.
X plus 2 to the second power. Let's try it. So what's beautiful about Desmos is we're going to write something down. We're going to go to Desmos and we're going to see if it's right.
Wait, no, negative 2.
So X minus 2 or X plus 2?
Squared.
So what do you guys think? Is it X plus 2 to the second power or X minus 2 to the second power?
X minus 2.
What do you do if you're not sure?
Set equal to 0.
Desmos.
Either set it equal to 0 and solve it algebraically, or you use Desmos, one of the two, right? So when in doubt, you write it down, you go for it, and you see if you're right or not. So, and don't worry about if you're right or not, you learn from it, right? That's the important thing. So let's take your first conjecture and let's learn from it. So you said X plus 2 to the second power. Okay, everybody go to Desmos. Here we go. Deselect the previous one. Let's go into the second row, type in the conjecture. Remember, conjecture is just an educated guess, right? You guys use that term in science classes. It's kind of like a hypothesis, Okay, so y is equal to, everybody go to Desmos right now. On your computer or on your phone, iPad, whatever you guys want to use. So we're going to type in X plus 2 to the second power. Whoops, got to type it in correctly here. So let me start over. There we go. Okay. So that's close, right? But not quite, because the x-intercept's at -2. So that's a good conjecture, but we got to modify it and learn from it because that has an x-intercept at -2, not +2. So how should we modify it? How should we modify it?
Switch the sign.
Switch the sign from a plus to a minus. So no good. Okay, so that's not accurate. So let's try something else. So we try this, and let's try it. Let's see what happens. And that's the beauty about this is that you learn from your mistakes, you learn from your guess and check, and then as you learn and you gain more and more experience, then you can predict the future, right? That's what we do. So I'm going to go down to the next row, and let's don't delete it. Learn from it. Just go down to the next one and change it. Okay, that's what I do. And so you go x or y is equal to x minus 2 to the second power. Deselect the first one, the previous one. Just turn off the color, and voila, you get the same function. We have an upward-facing parabola. Click on your x-intercept there at 2. And you'll see that we're golden right there, okay? Okay, so now that's one possibility. What's another one? Let's get creative here. How can we modify this slightly Because this, believe it or not, there's an infinite number of functions here possible. What's another possible function? This goes out to everybody in my class, online and in the class. What's a variation of this that would still have the same x-intercept at 2, but be slightly different?
Can you put a 4 instead of a 2?
Oh, so change the exponent? Okay, so take it to the 4th power instead of, let's try it. Okay, so let's do it. So when in doubt, you do it, all right? So let's investigate. So f of x, here's our next idea. So what Seth said, I don't know if you guys heard it online. He said change the power from 2 to 4, another even number. So let's take it to the 4th power. So let's do it. Okay, so y is equal to x minus 2 to the 4th power. So use that a to the power b button, or you can use shift 6 on your keyboard. They'll put an exponent up there. Change it to the 4th power. So Seth, your idea was to change the exponent from 2 to 4. Is that still valid?
Yeah.
Everybody see that it's still valid? It has the same x-intercept there? So what's the only difference between the two? In terms of the graphical feature, in terms of what it looks like?
It's thinner.
It's thinner. What else happens at the vertex? Yeah, it flattens out a little bit. So when you increase the exponent, it flattens out near the vertex. Okay, but that's still valid. So this one's good. This one's good. What's another variation that we can make? Get creative. This goes out to everybody online and in the classroom. So I'm not leaving anybody out here. What's another variation? Okay, look online. Look on the chat, guys. That's valid too. You can change it to the 6th power. What else can you change to make a modification other than the exponent? Okay, Bella, you get a little crazy there. I like it, but yeah, that would be really flat at the bottom. What else can you change, but it still maintains the same x-intercept? Don't change the exponent. What else can you change? Oh boy. We're having a little Zoom problem here. Get creative here. So not the Shane, not the intercept. You want to keep the same x-intercept. Think about what you guys did in algebra 1 and 2 with the parabolas. What else can you change? That changes maybe the shape. You guys get creative, guess and check, type something in. You got to keep the same x-intercept though, but you can change something else other than the exponent.
Mr. Andrew, I have a question. Does
Yeah,
it
go
matter?
ahead.
Does it matter if the parabola goes up or down?
Well, this one goes up, so you can change it so it goes down, up, going up. So if I just said write a function that has an x-intercept at 2, then the answer would be no, it doesn't matter, and then you can get really creative. But let's keep it facing up just because the graph is showing that it goes up. But how do you change the shape of a parabola, guys? You're on the right track there, Jalen. You just got to figure out where you're looking there. Where do you change to make that either go up or down, or change the shape to make it go more narrow or wider?
I was looking at the number in front of the parentheses.
That's right. It's called a coefficient. So where do you want to change it to? Well, a
I don't
negative.
know. Go ahead.
Well, Seth said make it negative like you did, but they'll make it go down. So just make it some positive number, because right now the coefficient is 1. That's right here in front. Right now it's 1. So choose another number. Get creative.
2.
2, thank you. Okay, so let's try it. So f of x is equal to 2 times the quantity of x minus 2 to the 2nd power. Let's try that. All right, you just pick a number and go for it. Get creative like Spencer just did. So we got y equals 2 times the quantity x minus 2 to the 2nd power. And notice that it's still a parabola, it's just skinnier, it's steeper. All right, still goes up, but it's just steeper. So you could change the coefficients and also you can change the exponents, but you just got to keep it even exponents. Okay, so remember, let's make a little note here that the exponent has to be even. So even exponent, even exponent, even. Exponents must be even, but you can change the coefficients and really get creative right there. Okay, so if you see a bounce, the exponents have to be even, but the coefficients can change. So I noticed that online right now, my Zoom is, your videos are not responding well. Can you guys online hear me okay right now? Jalen, yes. How about everybody else though?
Yes. Yeah.
Okay, because your videos are sketchy, so at least you guys can hear me. That's good. Okay, let's transition here to the second graph. Okay, we have two x-intercepts in this case. We have one at -2. We have one at 1. So we have two roots, which means we have two x-intercepts. Okay, so what's going on at the first one? What's going on the second one? So let's analyze one at a time. Okay, so let's go around the room here a little bit here. Pakran, what do you see happening at -2? Do you see does it cross the function cross at -2 or does it bounce at -2? Okay, so we see a bounce here. So a bounce, okay, at x equals -2. Okay. Ariana, does that mean that we have an even or odd multiplicity at -2?
Even.
Good. So that means that we have an even multiplicity there. Okay, and then we have two x-intercepts. So Destiny, what do you see at 1 here? Do you see a bounce or a crossing at 1?
I would say it bounces at 1.
Yeah, bounces at 1. So do we have, let's write that down. So we have a bounce at x equals 1, and that also means that we have an even multiplicity there. So believe it or not, guys, since we know that we have two even multiplicities, we should be able to write a possible function. So let's get creative. So here we go. We're going to write the possible function, and then we're going to test it in Desmos. So I'll take a volunteer here. Use your knowledge from the previous one. Who's got an idea?
X plus 2 times x minus 1.
So Daniel said x plus 2 times x minus 1.
Squared on each of those, like in between.
Yeah, we don't want to keep it to the first power because that'd be odd multiplicity, right?
X plus 2 squared times x minus 1 squared.
So Daniel said x plus 2 squared times x minus 1 squared, even multiplicity on both. Could we change the exponents to something else if we wanted? Give me another even number possibility.
4.
Yeah, maybe 4 or something like that. Let's test this. Let's go to Desmos. Everybody type this in. And again, this is what you guys are going to be doing here. You're going to be learning from the past, take your experience from the past, and then using Desmos to help you see if you're correct or not. So, and I'm not telling if he's correct. The graph will tell him, right? Okay, so you don't need me on this part. So everybody go to Desmos, so let's put in his conjecture. So he said y is equal to quantity x plus 2 to the second power times quantity x minus 1 to the second power. By the way, if you guys have questions, don't hesitate. Just turn on your mics and speak up. And by the way, everybody, look at the responses online too from Alexis and Tyler. So Alexis is the same one as Daniel's, and then Tyler has a variation. He changed the coefficient from one here to 1/2. So let me put Tyler's idea in here as well. So he said 1/2 times x plus 2 to the second power times x minus 1 to the second power. Let's type that in as well. So you can get creative here and test your ideas simply by putting it in Desmos and see if you're right, which is kind of cool. At least I think so. It's kind of nice to have a tool like Desmos to see if you're correct. So on the second one there is Tyler's idea. The first one is Daniel's and Alexis's idea. Both are valid because both have two X-intercepts, one at -2 and one at +1. Let's click on them and you can see them. Okay, so how are we doing in class here today? Yeah, and then online, how we doing? Your videos are not working well, so type in something in the chat because you guys, some of you guys are frozen. So give me a response online on the chat. Or turn your mics and just talk to me, one of the two. Because I'm having a lag problem right now. Hang in there, Maya. Okay, I understand. Thanks for being honest. I appreciate that. Okay, you guys are doing great. Let's continue on the theme here. Third one, we have something different. So work ahead of me on this one. What do you see? Okay, so what do you guys see? So how many X-intercepts do you see now? Just talk to me, guys. How many X-intercepts do you see? One. How many roots do you see? One. Remember, root is an X-intercept, in terms of the graph. So we have one root. We have one X-intercept. They're similar in concept. All right, at X = 3. Excuse me, -3. Okay, do we have a bounce at that point? Does the function bounce off the x-axis at -3 or does it cross the x-axis? Let me hear you loudly. Yeah, it obviously goes through that x-axis there, crosses it. So it crosses through, okay, at X = -3. That implies something. What does that tell us? What information does that tell us?
It's a negative multiplicity.
Yes, Bella, can you repeat that so I can hear you better?
It's a negative multiplicity.
Well, not negative, but something else.
Oh, odd. I'm sorry. I like.
It's okay. We're all good. Thank you. All right. Yeah, so it's an odd multiplicity. Very good. All right. So odd multiplicity. We're talking about, 1, 3, 5, something like that. Third power, fifth power, seventh power. Could even be the first power, but it's not linear, so it's not going to be third. It's not going to be the first power. So now we need to write a possible function. So I need someone else other than Daniel. He took the last one. I need someone to volunteer on this one. Tyler actually gave a thought, so you guys can critique his thoughts too in the chat. Agree, disagree, or come up with a different idea. Seth agrees with Tyler. So does a few other people here. So put up another variation, you guys. I agree with that. So f of x could be x + 3 to the third. Give me another variation.
X + 3 to the 5th.
Okay. So I don't know if you guys heard that. It says that x + 3 to the 5th. Okay, let's test the idea. So let's put them in Desmos. Here we go. You always check your work. You always validate it. So like I said, you're going to be using Desmos a lot when it comes to graphing functions because it can graph anything, literally any function, which is pretty awesome tool. Not only that, it's easy to use. It's a lot easier, in my opinion, than the TID4. A lot faster, a lot easier. I don't know, what do you guys think? Because I'm sure you guys used the TID4 back in Algebra 2. I'm sure. Do you guys prefer Desmos over the old calculator? Because I've taught with the TID4 and I've taught with Desmos, and I prefer this. It's just way faster, way easier. Okay, so these are good variations here. You can even change the coefficient. All right, let's pause and reflect here. Any questions up to this point? Because this is the first half of your activity that you guys are going to be working on into 7B2. And this goes to anybody online. Again, your videos are all frozen. So give me some, just use your mics or the chat. How are we doing so far? Bella, your last comment was valid too. You guys online okay?
Yeah, good.
Yep.
Yeah, just go and take care. It's Odessa, it's straight across right over there. Really easy to access. Or there's one there and there's one there.
Okay.
Either one. Okay, let's go to the second part of the activity here. And this one here, this one's totally different and it's challenging in its own way. Okay, so you're going to be expected to graph or sketch. Let's underline the word sketch. Draw a possible sketch, which is a graph, of a polynomial function that has all the following characteristics. So the domain has to be from negative infinity to infinity. So let's read the characteristics and interpret, because if you don't know what it means, then you can't do it, okay? So what does that domain mean? And for the people online, you can just turn your mics on if you want to speak up. What does that mean in words?
It's infinite either way.
Be more specific. Remember, domain is the set of all possible x values, and the range is the set of all possible y values. So,
On the x-axis, so we just go far left or right.
okay. So, what, you guys, in other words, though, how do you say that domain if it's from negative infinity to infinity? Ah, okay. See, now it's coming in. So it's a set of all reals. X can be any real number. So this means all real number, any real numbers. Okay, which means there's no restrictions. No restrictions. And because of that, there are no holes, no gaps, no asymptotes. Okay, so no holes because there are no restrictions and there's no vertical asymptotes. So when you need to know all of this, because if you didn't, you wouldn't be able to graph a possible function. So when I say the domain is all reals, I mean no restrictions, no holes, no vertical asymptotes. So write down everything right there. That's what this means right here. Take a moment and interpret that. And then Shane, I saw your Shane, am I going too fast? Okay. Hey guys, if I ever go too fast in class, you can just let me know. And everybody online too. Just say, hey, Ainsworth, slow down. You know, I don't want to blow anybody away, okay? Okay, so domain is all reals, which means no restrictions. The range is from negative infinity to 5. I want to modify this, okay? To make it just a little bit easier. Make it closed at 5. So fix this one. So from negative infinity to 5. So I want to interpret that. So tell me about the range in words here. So what is the range or the set of all possible y values if it's from negative infinity to 5? In words. In words.
All reals less than or equal to 5.
Say it again real loud for everybody online.
All reals less than or equal to 5.
Yep. All reals less than or equal to 5. So let's write that down. So all reals less than or equal to 5, or in other words, y is less than or equal to 5 in terms of symbols. Okay, because it's closed at 5. So that's why you said less than or equal to. Very good. Okay, and that's important to know. So the highest that this graph can go is up here at the very top at 5. So let's highlight. Let's draw a dotted line. The graph, wherever the graph is on this plane right here, it can't go above that. It's got to be below this graph. If the y values have to be less than or equal to 5, then it can't go above that horizontal line. Are we clear on that? Do everybody understand what I'm saying? Yeah. Okay. Because all the y values is like the y values go up and down, you know, x values go left and right. Okay, and it says that you have one negative x-intercept, and there's only one root there, which means the multiplicity is 1. So we need to pick a negative x-intercept here. So Ariana, just pick a negative x-intercept for me that I can plot. Be creative up there. There's a bunch of negative x-intercepts.
-3.
-3. So Ariana picked -3. So at x equals -3 is a negative x-intercept. Multiplicity of 1. By the way, 1 is odd. So does it cross at -3 or does it bounce at -3? Cross or bounce is an odd number. Multiplicity is 1. 1 is odd. So cross or bounce?
Cross.
Okay, it crosses, it has to cross at -3. So crosses at x equals -3 because it is an odd multiplicity. So if you were going to graph this thing, you'd have to go something like this right here. Look at the screen. Or it can go the other way. Maybe the function goes this way. I don't know. I suggest you use pencil on this one here because you might have to do some erasing when you're testing. So you're going to have to sketch this here in a minute. And then we need a positive x-intercept too. So, and there are 3 roots there, which means it has an odd multiplicity because, 3 is odd. Okay, so we need a positive x-intercept. So Destiny, pick a positive x-intercept here so that we can play with it.
2.
3? Did you say 3?
I said 2.
2? Okay, so you said 2, so let's put in x-intercept to 2. Now, if it has an odd multiplicity, it has 3 roots, which is an odd multiplicity. That means it has to cross at x equals 2. So it can a function either can do this, or it can go the other way. Function can go something like this. So now comes the creative part. You got to satisfy all that criteria. Now you have to draw a sketch. And this is where you have to get creative and you have to draw a function that has no holes, no gaps, no vertical asymptotes. It has to be continuous. It has to go through -3. It has to cross through the x-axis. It has to cross the axis twice, once at -3 and once at 2. So start sketching. And when you draw one, I'm going to come walk around the room. And for the people online, just go ahead and work ahead. And I suppose, well, your videos aren't working right now, so I can't really see your papers, even if you hold them up to your cameras. But everybody go ahead and start working on this. When you're ready, call me over and I'll peek at your papers here. And again, this is where you sketch, you draw it, you try it. So get your pencils going. It has to go through -3 and 2. It has to cross the x-axis at both of those points. It can't go higher than the horizontal line at 5 because the range is less than or equal to 5. And it can't have any holes or asymptotes, vertical asymptotes.
Mr. Ainsworth, speaking of working ahead, is the 7B2, is that just page 4 or does that encompass 5?
Let me check right now, buddy. Hang on. So 7B2, your activity that we're gonna start working on is on page 4. And then on page 5, everybody write down on page 5, that's 7C1 prep. So to answer your question, Tristan, on page 5, label the top 7C1 prep. That's not for right now. That's tonight's homework or tomorrow's homework before the next session.
All
Are we
right.
good? Yeah, so we're not working on page 5 right now. There's a video already online on that. So everybody, your activity's on page 4. We'll get to that in a minute. Okay. So I want to see this right here. So draw a little sketch. Okay, you're almost there. But it has to go up. The range is less than or equal to 5. So it's got to go at height 5. It's got to go 5 units. Oh, it actually is. Oh, I was looking at your dotted line.
Oh, sorry.
Your dotted line should be at 5
Yeah,
too.
sorry.
So actually, that's good. That's a possible graph. Well done. Okay. Yeah, and that's one possible graph too. Oh, it's got to go up at height 5 though. So let me see. Where's the x-axis here? So 1, 2, 3, 4. It's got to go up height 5. So make it go as high as 5. About 5. That's good too. That's good. Keep going there. Okay, so this implies that it keeps going up and up and up and up. But you can't go higher than 5 because the range is less than or equal to 5. So have it maybe face the other direction. Instead of upward facing problem, maybe downward. Yeah, good. And this implies that it goes up here forever. The range is less than or equal to 5. So the function, like it makes sense, it can go up to 5 units high, but then it's got to come back down. Right. And it's got to intersect those 2 x-axes. There we go. That's a possibility right there too. Okay. The people that I just checked right there, if you're good, go ahead and start working on your activity. Okay. That works too. That's a possibility. That's a variation. That's fine. Hey, there you go. That's a good variation right there too. Good job, Kirka. There you go. Let me see that. That was the prep. I got this 7B1. This should have already been done. This is 7B2 prep that is online. That was done in the last couple days before break. So keep going. There you go. That's it. You can get caught up on the previous one later. Okay. There you go. So the downward one, not the upward one. Yeah, there you go. Oh, next time. I have some extra pencils right over there. Let me grab one. Teachers always have supplies. Okay. So it's got to go through -3 and 2. It's got to cross them because they have odd multiplicities. So the function's got to go through it. The range is less or equal to 5. So it can't go higher than 5, and then it's got to come back down again. And it's got to go through these. Sure. You know where that.
Yeah.
Straight across there or one over there. Does anybody online have any questions as they're working through here? I know I can't see you guys, so you're gonna have to just speak up using your mics because I can hear you, or you can type in a question in the chat, one of the two. Mics would be a whole lot easier though. This is going to be the challenge being at home. Yeah. Tristan, can you still hear me, bud? Okay, because your video is working, but everybody else's is not.
Don't know what to say about that.
Okay, don't worry about it. We're just gonna. These are the things that we have to work through. Shane, let me see here. Talk to me, Shane.
All right. So it says at the negative X-intercept, there's only one root, which has a multiplicity of 3. But
No. Multiplicity of.
Oh, I thought it bounces.
No. It has if it has only one root, the multiplicity is 1.
Yeah, I think I misread it or something.
Yeah.
That's what confused.
Yeah, exactly. That should confuse you right there. So change that. It's an odd multiplicity, so it's got to go through the x-axis right there, bud. So the online people, you guys can speak up and ask questions as you go. And then what I'm going to do is when you guys submit your work today, I'm going to download some student work and show you guys on the next class session some student work, and we'll analyze what went well, what's good, what needs to be improved, that sort of thing. Yeah, I suppose it could go do that. It has to go up to 5 though. All right, so 1, 2, 3, 4. It's got to go up 5 high because the range is less or equal to 5. So the high point is 5, but typically functions, a little bit more. We can more like these functions through here. So do something like this, but going down. Okay. Shane, did that fix things on your graph?
Yep, it fixed it.
Okay, you know what? Your video is working here. Let me see your graph. Put your paper up to the camera. Let me peek. Okay, so your function is going upward. Okay, but you can't go, the range is less or equal to 5, so it can't go above 5. So instead of going upward, Shane, make it go downward. So you're gonna, let me show you what I'm talking about here. So it's this is some of the possibilities that I saw in class. The function's got to go through -3. It's got to go up. Can't go any higher than 5 because the range is less or equal to 5. But then it's got to come back down somehow, and it's got to go down. It's got to cross a 2, and it can go down forever, but it can't go up forever because the range is less than or equal to 5. So the maximum is 5. There's no minimum. but there is a maximum. So change your graph slightly. Did that make sense? Okay. So that's why I need to be able to see your work. So we got to figure these things out when you're online. And of course, with you guys in class, it's easy. I just walk around and check things out. Okay. So everybody should be transitioning to the activity, which is on the next page in your notes, 7B2 activity. Unless you have questions on your example here that you're working on. So your activity 7B2 is in your notes following 7B1 prep. Here we go. So this is what everybody should be working on now. And as you do so, you can ask questions as you go if you like. Part 2, number 2, this is the part where you're going to be using Desmos. So use Desmos to validate. Everybody write that down in the margin there in number 2. And what I'll do on for next class session, I will download some student work on this, and I'll let you guys know and give you guys some feedback on what you did well and what you need to modify to improve your work. Now, for you guys in class, you guys can be talking to each other. You're not restricted here. So you can show each other your papers. You can't pass papers around right now, but you guys can hold up papers. You can show each other your work. So and make a new friend while you're at it. Okay. All right. And then I know you're over here by yourself, but in the future we can get you closer to other people. Yeah. Okay. Oh, I forgot. We're going to skip part B. Everybody in the margin, I haven't talked about discrete functions yet. So put down in the margin on part B to skip part B. It's Ainsworth has not talked about discrete functions yet. So we're going to skip this temporarily. Thank you, Daniel. I forgot about that. Okay, but you guys should be able to handle the part A and C. And the best thing to do is, use pencil, obviously, because even when I do this, because I do everything you guys do, you might need to erase sometimes. You try something, if it doesn't work, you erase it, modify it until something works, right? So guess and check, modify. And then again, you guys in class, you guys can be showing each other's work. You can talk to the person next to you, communicate. That's why you're here. Okay, and everybody online, if you have questions, just speak up. I can hear you guys.
Yeah. So like one of them, it says it would be like I wanted it to be one of them. Okay.
Go. I'm so happy to meet you guys for the first time face to face. To see you guys are actually people. You're not just some face on the screen. I can't wait to meet everybody else. Again, we can come in here. Oh yeah, I was the advisor of the guitar club a couple years ago, 3 years ago. And the guitar club gave me that guitar that's signed. I don't know if you can see it, but it's signed by like 30 people. Because we had about 30 guitarists in here during lunchtime. Yeah. Back when the activities were going on. And they gave that to me after I got in my big accident 3 years ago. I wasn't able to come back to school. Because I crashed on my motorcycle. Did I tell you this story? No. I wasn't able to finish the school year. I was out for 4 months. And I was paralyzed, and I actually got back on my feet and started to walk again. And when I came back, they surprised me with that. And because I got back healthy again and was able to teach again. So it was pretty neat.
What did you run into?
I used to motocross and do all the extreme jumps, on the supercross tracks and everything.
Yeah.
So I used to ride it with my son.
Yeah.
And I hit a 90-foot jump, and I hit it too fast and overshot it. And when I landed from like 30 feet up, my back exploded, and I have 2 9-inch rods holding my back together. So I'm a walking miracle, actually. The doctor was surprised that I'm actually survived the accident. So I broke all my lower ribs, My back shattered. Surprised I didn't break my neck. And like I said, I was paralyzed for a day, and I got blessed that I got my feeling back in my legs, because my life would have been changed. Well, was changed. I don't motocross anymore. I don't do a lot of things anymore, but at least I'm able to walk, so I'm happy about that. And I'm still able to teach and work with kids. So
Terrible.
it was 2 days ago on the 5th, Monday, was the 3-year anniversary. It happened on April 5th. So I wasn't able to come back for the rest of the year. But I am back. Not as strong as I used to be, but I'm back. Okay, all right. Now, we're going to be doing the same thing as we always do. We're going to be submitting, scanning and submitting your work in Canvas. In Canvas, if you take a look at it, the prep that we did today is in there. Let's check it out. So yeah, 7B2 Prep 2 is in there. It's published. 7B Activity, everything's there. So if you guys want to at home and also in the classroom, you can always scan your work, get it uploaded. Some of the students are having problems doing it at school, so if you need to do it at home, that's fine. Just make sure you scan and upload your work, within the right amount of time, since you're done with your activity here today. And then when you're done with activity 7B2, the actual activity, later on today, you guys can scan and upload that later on, and then I will discuss it in the next class session. When we come back, we'll look at student work, we'll make corrections, we'll ask questions, do the normal thing. Sound good, you guys?
Yep.
All right. Everybody online, give me a shout. Did you guys hear that? Everybody good on that?
Scan into Desmos, right?
Into Canvas.
Oh yeah. Sorry, my bad. But PDF scanning, right?
Yeah, you got it, Tristan. So if you guys have questions on this, like I said, you can talk to each other. You can call me over and ask me questions too. We need to really get used to talking to one another again, so you guys can discuss things. We can all discuss things in here, okay? So feel free to do that. You hear?
Say that there's not a y-intercept
Okay, which one?
on C.
Okay, let me read it. So
It's kind of doing like we did.
So what is your question again?
Is there not a y-intercept? I feel like it's like a restriction.
Oh, it doesn't say that. So it could have one. So if it doesn't say no y-intercept, then it means it could have one.
Okay.
So go ahead and cross that y-axis if you want to.
Okay.
Yeah. You would have to say no y-intercept in order to have that kind of restriction,
Okay.
but it doesn't. So go ahead and go for it. You remember on number 2, whenever you get to number 2, whatever you write down on the function, go to Desmos, type it in and check your conjectures and see if it's working for you. That's the one. That's where I want you to put in Desmos.
Oh,
Check.
okay.
Yeah, so go ahead and type it in.
Okay.
And then if it's similar and it has the same X-intercepts, it might have different shape, Ariana, that's okay. But it has to go through the same X-intercepts. And if it does, then you got it, okay? Yeah. But the shape can change. Because remember how you can change the coefficients in the front of the function?
Yeah.
You can put a 1/2 there or whatever number you want. But it has to be the right X-intercepts. And as you guys work online at home, if you have questions on your activity on anything, you gotta speak up. I can hear you wherever I am in the classroom, okay? And I'll try to help you out the best I can.
Is this one page?
Yeah, activity, yeah, there's only one page,
What
and
should
then,
the next page was?
yeah, the next page is 7C1 prep.
Okay.
Let's, let me bring that up, and that's what Tristan was bringing up. So, let's see here, 7B1, 7B2, yeah. So this right here that you see in your notes, Daniel,
Yeah.
this is 7C1 prep, 7C1 prep. This is tonight's homework. Let me see, this is on page 5, right?
Yeah.
Oh, Mr. Ainsworth?
Yes.
All right, so because I had to hand draw everything, whenever I try to scan it, it looks really bad. So is it fine if I take a picture of it instead?
Well, you can't upload a picture file. You have to upload a PDF using your scanning. So, yeah, PDF's only in Canvas. So just do your best, and I'll take a look at it. And then if there's an issue with it, I'll comment back to you. Just do your best on that.
Okay.
Do you have your notes? Oh, you weren't able to print today's Are you talking about today's prep or are you talking about the activity itself?
Both. I can't print either. I don't even have my notes with me.
Are you home or somewhere else?
I'm at Florida.
God.
Yeah.
It's not like I can jump in my car and drop off a set of notes, can I? I can't jump in my car and drop off some notes for you, can I?
No, I don't think so.
It's like 3,500 miles away.
Yeah.
The best you can, Shane. All right, and just scan and submit what you can.
Okay.
Your best. When are you coming back?
I'm not entirely sure. It could be a few days. It could be a week. I don't really know.
Okay. Are you with friends or family?
Family.
They don't have a printer there?
Nope.
Yeah, okay. Well, maybe they have a friend in the local neighborhood where you can print out some notes.
Yeah.
So
I'll see if I
talk to
Wait, what?
talk to your parents and see if they have some neighbors that have a printer so they can help you out, because this stuff's kind of complicated to do it all freehand.
All right.
Okay. That's tough.
Mr. Ainsworth, I have a question.
Yeah, bring it on, Bert.
So for number 2, well, I have 2. For number 1, I don't understand what it's asking for part C, where when it says there are 3 roots at one of the X-intercepts and there's 2 roots at another one.
That's a great question. Okay, so what that means, like, let's take a look at one part here. So on part C, there's when it says there are 3 roots at one of the X-intercepts, that means it has a multiplicity of 3.
Okay.
Multiplicity equal to 3, and that's odd. So what does it tell you about what's going on at that root?
It crosses.
Yeah, so at that particular X-intercept, whatever X-intercept you choose, that means since it has 3 roots there, which is an odd multiplicity, it crosses there. Where on the bottom one, it says 2 roots at the other 2 X-intercepts. So if it has 2 roots, that's an even multiplicity. And if that's the case, what does it tell you?
It bounces.
That's right. So if it has an odd multiplicity or an odd number of roots, it crosses. Can you see my screen here? I'm making some notes for you. And then if it has 2 roots or an even multiplicity, it's going to bounce at that X-intercept wherever you plot the X-intercept. And so notice that there's a lot of creativity involved in there, because you get to choose the X-intercept, and wherever you choose it, it's got to bounce there. Does that make sense?
Oh, so in the middle. So okay, yeah, I get that.
So 2 X-intercepts have 2 roots or even multiplicity. So you're going to have 2 bounces, and then at one of the X-intercepts, it's an odd multiplicity, so it's got to cross. So there's a total of 3 X-intercepts. You know, 1 that's negative and that's 2 that are positive. So 3 total X-intercepts. You're going to have 2 bounces and 1 crosses based upon the information there.
Okay, that makes sense.
Does that help you now?
Yeah, and then for number 2, I've had a question on equation B. So
okay,
what I have is parentheses x plus 1 parentheses to the 2nd power, then parentheses x minus 3 parentheses 2. So they're bouncing. They're just the line. I think the proper term is it's a maximum. That's when it's pointing up, right? Or is that no? It's minimum.
No. At the top, like the high point is a max. So there's going to be a max at 3 and a max at relative max at -1. But your function, when you put it in decimals, does it go up or down?
It goes up. That's my problem, and I don't know how to get it down. I tried putting a negative sign in front of the whole equation. I tried giving x negative, and then I tried giving the exponent negative, and it still went up, or just looked really funky.
Well, I think you should try the negative idea again, because if you insert a negative in the front, like let me switch colors. You see, look right here. Make the coefficient negative. That should do. Try it in decimals again because you're on the right track.
Yeah, it was just that.
You got it?
Yeah,
Okay.
thank you.
You're welcome. So you see, guys, that's the communication part that needs to happen. So when you guys have questions, everyone needs to interact like that. And that way we can help each other out no matter where you're at, whether you're online or in the classroom, it doesn't matter. So I forgot, I don't have the schedule with me right now. What time is this class end? Say a little bit louder.
10:40.
10:40? Oh, so yeah, so we have 2-3 minutes. Okay. This is where you want to log out. Everybody, you guys have a great day. It was good working with everybody. And if you have, you guys know how to get a hold of me. So if you need anything, then, obviously let me know. And I'll be available if you need anything. And remember, just everything's as normal. We scan and submit all our work. Do your best, and I'll see you soon. And I think, no. Where'd Marianne go here? So, okay, I don't see her anymore. Okay, so, she's still joining. Okay, that's what's going on. Okay, well, you guys, hopefully you had a good day and continue having a good day. It was great to see you and meet everybody. And I look forward to seeing you guys soon, okay?
Bye, Mr. Ainsworth.
Bye, you guys. Good seeing everybody.
See you Friday.
Hey,
Bye.
guys. So Marianne, we had some little tech problems.
Yeah, everything was fine until I was just scanning my work, and then my Wi-Fi just kicked me out real quick, so I just got gone.
I know I'm having some internet issues here too, so I'm gonna have to reboot my computer right now. So, do you have any questions before you go?
Nothing yet. I completed all my work, and I was just gonna turn it in right now.
Well, you're awesome. Very good. Okay. Well, it's good to see you guys. You guys take care, and I'll see you guys soon, okay?
Alrighty, bye. Have a good day.
You. All right. I'm going to end the session. I have to shut down my computer and reboot just to make sure everything goes smoothly here, guys. So I'm going to close out the Zoom session here.